Hey everybody! This is Larry. This is me going over Q4 of the weekly contest 382. Minimize all of remaining elements using operations. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. To be honest, I didn't know how to do this one at all. I had some ideas around greedy, but I didn't really play around with it, or I wasn't able to kind of get the answer, even though I had figured out some of the properties. So let's go over some of the properties before we kind of go, right? One is that we're trying to minimize a bitwise OR, right? So what does that mean? When you're trying to minimize bitwise things, you want to care about the most significant bit first, because in a greedy kind of way, if you can, let's say you have, let me kind of visualize something real quick. Yeah, let's say like your end, this is your answer or possible answer. If you can remove this and you don't, it doesn't matter what the rest of the answer is, right? Even if you optimize it all to be 0, it's still going to be worse than just optimizing this to be, the first number to be 0. So that's one of the first things that I would think about when turning greedy, right? So that's step one. Well, that's the first observation. And then the second observation, and yeah, I think that's actually, is there a second observation? I think that's the main observation. And from that, I was kind of trying to play around with different things. Initially, I thought, so that's one idea of being greedy. And then the second one was that I was just basically, I just couldn't reconcile during the contest, and this is a little bit of retrospective. Feel free to fast forward a little bit. But during the contest, basically through this idea, I was trying to figure out how to do one bit at a time, like trying to do this and then do this and then do this and so forth. But I wasn't able to kind of. So the way that I did it is that I count the number of ones in that bit, and then just kind of like try to optimistically merge them in a way such that we are able to get a 0 there or something like that, right? For example, if there are 4 numbers of 1 in the most significant bit, and you have 10 counts, or k is 10, then you can just remove all of them, and then you have 6 for the future, right? But if the corollary, another thing about this though is that for this problem, the other observation is that to remove the most significant bit, let's say you have 5 of them have ones, then you need 5 operations, assuming that they're not all ones, because if they're all ones, then there's no 0 to kind of AND it against. Otherwise, it takes, if you have 5 ones, then it takes 5 AND operations to get rid of it by doing a bitwise AND with a 0, right? Yeah, and like I said, you want to do it in a greedy way, in that, okay, if the most significant bit takes 10, has 10 ones, and your k is 5, then you actually don't even do any OR operation on that bit, or at least not with that as priority, because it doesn't affect the answer, right? Because if you have one bit left, it still gives you a 1. So you definitely need to be better about. So you need to kind of just move on. So from that, I actually did kind of come up with a answer that was maybe like, say, 90% correct, but I was missing one step, which we'll go over in a sec. Because I was trying to merge them step by step, but I didn't know how to merge them in a correct way. But this is, honestly, it is an 8-pointer, so maybe, this is obvious that this is definitely a hard problem, but the idea here is to it's the same thing as what I just said, but in a slightly smarter way. And the idea here is that you don't have to do the merging step by step. You just kind of the 2 type of problems that I want to kind of draw inspiration from for this solution, right? One of them is binary search for the answer. I'm not going to go over that in this video, just because it's an 8-pointer. It is probably already going to take a long time, this video, so I'm not going to go over binary search for the answer. But the idea is that, okay, let's say you have an answer. Can we get an answer, or like, are we able to have this thing as the answer, kind of. So that's kind of the concept. It doesn't apply one-to-one property, but that's the concept. And then the other one that I want to bring up is kind of like that kind of reminds me of, is like a greedy try solution, right? And what I mean by that is that in the past you have some like XOR or bitwise XOR or bitwise and operations, and then you kind of do some in a way your path is forced every bit of the way because you're trying to do greedy, right? And what I mean by that is similar to what I said earlier, right here. So then we try one bit at a time with the most significant bit, similar to being in a greedy try solution, which is also similar to binary search for the answer, I guess, actually. So maybe it's not that important, but it's still kind of just for visualization. But basically you try, okay, the idea is, can the first digit be 0, right? And then to answer this, you have to implement something. If the first digit is 0, how many operations would it take, right? And then after that, and then it will be, do we have the k for it, right? And then in going back in a greedy kind of way, if we have enough k, then we will make this 0, right? Because we're trying to minimize it, so we will make it 0. If not, or if it is not possible, if it's all ones, then first digit is 1. Oops, and then now that we figure out one digit, what do? Well, now we figure out the second digit, right? Can the second digit be 0? And this is the same idea, right? Except for like now, and that was kind of the way that I was thinking about it, but during the contest, but I was off by, I just was missing one idea, which we'll go over in a sec. But this is the core idea about this type of problem in general. And here, and of course, this is just copy and paste from this, to be honest, right? So then, y'all are smart, so yeah. Right, whatever, right? And ... And that's basically the idea. And then and maybe for the second digit, it should be that, this is also with the condition of, given that the first digit is whatever we got from the first part, right? So yeah. So then basically now it becomes a prefix, right? And I think the clean way of doing it is maybe work through a problem, right? So yeah, I'm just gonna bang. Wow, banging randomly actually gives me like whatever, right? And yeah, right. So then now, and let's say k is equal to, I don't know. Well, if it's 10, I guess it's not. I just keep it, say 2, right? Well, 2, what happens? Let's go with the first digit. In the first digit, we have 3 ones, and of course, you can end them in some way. It doesn't really matter, but it takes 3 ones to do it. So the answer is no. The first digit has to be 1, right? Because there are 3 of them, and you only have k is equal to 2, right? So this is the answer for the first digit. And then the second digit is, okay, now we know that the first digit have to be 1. Can the second digit be 0? And then the idea here is try to figure out if you can get, basically the idea here is that and this is the part that I had trouble during the contest, and also just like visualizing it, is that because a lot of these problems for bitwise, you can think about them independently, but for this one, you're not they're independent, but you also need the previous thing. So the idea here is that you want to make, is there a way, or like how many operations to get it so that 110 is the 10 is the answer, right? And the idea here is that, okay, so this is 0 1, so let's say that means that if we have 0 and 1, that means that we have to merge forward, obviously, right? Because we have a 0 here and a 1 here, so to make this 1 a 0, then we have to merge forward, because, you know, so here you also have to merge forward. You merge these two, and then you merge this one, and then here, now finally, after three steps, you get 0 0, I think. So then now you can so then now that means that it gets rid of the first 4 as a group, but then now you have 1 0, which is also already good as a prefix. 0 0 is also good as a prefix, because it's not going to make this worse. It means that 110 is still a possible answer, because if you have 0 0 as the prefix, it means that, you know, the prefix is going to be 1, right? So yeah, and 0 1, so that means that this one you merge backwards, and as a result, that means that you make 4 steps, and of course 4 is bigger than 2, so 1 0 is not possible. So then now you have 1 1, and then now same idea, but then now you try to see if it can be 0, and 0 here you can actually, right? Because if you kind of just make this 2 operation, you do a and on the prefix only, then, you know, 1 1 0 and 1 0 1, this gives you 1 1 0 0, which is, you know, better than 1 1 0. So that means that it will take 1 operation, and here it will take 1 operation, so that means that this is going to be 0. And that's basically really the idea. Some zeros can be possible, so then the next number we could see if 0 is possible. It is not, so we have 1, and then also 0, no, so here's a 1. This one, man, I think these are just all 1s the way that I wrote it out, so that's my bad, actually. I guess random numbers are maybe not a good example here. But yeah, but the idea here is that for each of these previous bits, I mean, the 1s are actually not that interesting, but actually it's about making sure that the previous one also has to be 0. If not, then you have to keep merging them and counting them, right? So in this case, for example, if we're on the last digit, so this is 0, this is 0, and this is 1, this is 1. So then if you do a n, this is going to be 0, so that's good. But that also means that this has one merge. This is 1, this is 0. So that means that we still have to merge forward because we have a 1. So that, because it assumes that in the past, because we have that 1, we assume that it will merge forward in the same way, right? So that means that now this is actually the second one, and then the third one, it's going to merge, and then it's another 1. So even though this last bit only have 2 of these, given the prior constraint of this 0, you know, this is the bit that we care about. This will end up being a 1 because, you know, we could either make this a 1, we could either make this a 0, but then that means that this has to be a 1, so that means that this is the case instead. So yeah, so it just became like a minimization problem in a way, and yeah, that's pretty much it for this particular one. But yeah, that's pretty much it. So I'm just trying to think if there are any ways to say it. The idea here is that the prefix, so here is that, okay. So the idea here is that given the previous things that we cared about, the previous digits, the zeros are the digits that we care about, right? Yeah. So that's basically the idea here, is that yeah. And if we don't make all the zeros that we care about 0, then it means that we have to add a new, or we have to do the merging until all the zeros that we care about are the ones that we care about. And that's really the idea. And then you can't do it iteratively in a greedy kind of way, because the most significant bit matters the most. For some reason, I actually took a long time to implement this correctly. I don't. This is kind of bad, but yeah. But yeah, that's pretty much it. We do a bit at a time. So I mean, I'll go over the code, right? So basically, this is just saying, and maybe the way that I write this is pretty awkward now that I kind of phrase this as the zeros are the digits that we care about, right? So maybe you can even rewrite this as the way that I wrote this is a little bit awkward, but yeah. Yeah, so maybe k is equal to 0, right? And then I don't know. I mean, I'm tired to rewrite it, so maybe I'll just keep it this way. But yeah, basically here it's just basically all ones, right? That's basically what this tries to do. And then here target is basically saying, okay, I have all ones except for the current bit, it's going to be a 0. Can this be done? And we actually don't care about the rest of the bits. I don't know why I wrote it this way. I think I just kind of mentally copied it from someone. I don't think this is the clean way to kind of think about it. But yeah. And then here, this is just counting if they're all ones. If they're all ones, then we just skip it, go to the next one, right? Because if they're all ones, you cannot, there's nothing to be done. Otherwise, we check the number of steps, right? So we start the first number, and this is some bitwise operation. This basically just looks at the prefix for the first I numbers, or n minus I, or 31 minus I digits, right? So for example, if this shifted by I is just like the prefix of, I guess I could have used masked or something. I don't know why I did it this way. It's fine. Yeah, I think I would have, now that I understand it a little bit better, maybe I will have rewritten it. But yeah, but basically this is saying if the prefix cannot get to target, at least all the zeros of the target, then yeah, basically, well, the way that this is set up is saying that if there's a 1 here where there's a 0 in the target, because if there's a 1 and this is a 0, this will be a 0. Oh, sorry, this will be a 0. So this is saying that if there's a 1 where in the target there's a 0, where target is going to includes the current digit, but also previous digit as well. So if that's the case, then we have to keep on adding bitwise ANDing, and then we increment the step. Otherwise, we create a new group, right? We start a new group to merge forward. Yeah. And then at the end, one more step is that if the last group we haven't done it, then we have to merge backwards, like to one step. So that's pretty much it. Yeah. And if the number of steps we're merging is still less than k, then we can update O to the target, and this is just this is just, you know, and target is just O minus one of the digits, right? Because basically here, this is going to be, like I said, 1111111. This is going to, like, you know, some prefix, and then it just tries one number 0, and maybe the prefix has 0 already, and then you try the last number 0, and then the rest will be ones, but then you actually chop them off by the bitwise shift. so that's why it looks a little bit awkward. But yeah, and then this just kind of see how many times do we have to merge so that we have zeros in all the places we should have zeros from carrying over from before, right? Right, so that's basically the idea. The code is a little bit yucky, but yeah, just to kind of give you an idea, feel free to rewrite them. But yeah, so what's the complexity? Well, this is going to be 31 operations, or all of log b, where b is the biggest number or something like that, or you just want to say b as the number of bits, that's fine too. And then everything is O of n, so yeah, well, this is O of n and this is O of n, so this is going to be O of b times n, where b is the number of bits again. So yeah, that's all I have for this one. Let me know what you think. And yeah, you could watch me solve it live during the contest. I didn't solve it live during the contest, but I spent like an extra hour because I was just being dumbed afterwards, because I was debugging something that I didn't need to debug. I was confused on some of the things. Yeah, but you could see Larry grind if that that is interesting to you. I did try a couple of, like I said, I tried a couple of things during the contest. I thought I could greedily merge things in another way, but that was not true. And I kind of played around with even mentally some DP before I kind of came along with an idea that's very similar to this one. But like I said, I by manually merging it, but I didn't know how to handle merging in a correct way, because yeah, I didn't know how to merge it in a way that sets me up for the future. But it turns out the way to do it is that you don't need to merge them. You could try merging them again in the future, which is what this code does, and then see how many operations it takes. So yeah, that's all I have for this one. As I said, you can watch me solve it live during the contest and after the contest. Next, bye-bye. Okay, that is a weird problem. All right, still, we got through it. Oh, okay, so it's not even ready yet. I'm curious about Q2. How many people got Q2? 37? I don't know, that's a weird problem, but okay. Minimize all of remaining elements using operation. Okay, focus, Larry. Finish this problem. Okay, any I, and replace nums of I and nums of I plus 1. So okay, so you merge things together with an bitwise and. Okay. This 8-pointer, geez. Really sucks that I got the problem wrong, because that's it means that not a lot of people are gonna get this one, but we'll see. K could be pretty big. Okay, the question is, okay, so 1 bit at a time. One bit at a time. Right. How do I do this? All right, 1 bit at a time with greedy. Greedy should be okay. Oh no, okay, wait, you have to be careful because you can only do adjacent numbers. For some reason I thought it was any IJ for Z. Okay. How am I doing? I'm just kind of thinking about it. It's a little bit tricky. The 5-minute penalty is going to be rough. Oh, it's up to K. So you always want to do it, because you can only end up with fewer things. So it's not always greedy. Well, actually, it is always greedy. Right? Can we get rid? So K could be pretty big, but that doesn't even matter, right? So then you do a heap on the most significant bit on I, and then you greedy do it. I have to be very careful, but I mean, I think I know how to do it, but implementation is not super clear. And the tiebreaker is also not super clear. That's fine. Binary search, that's fine. Sorted list, also fine. Okay, and then what? Okay, let's go. Okay, right. But also we want to have a heap, and then for x line, whatever. Just do it this way now. Stop using fancy stuff for now. And I don't know that this is 100% right, but it should be right. I and I plus 1. So here we want to get the bits, right? Okay, so so that is terrible. So or is equal to nums of I or nums of I plus 1, and then n is going to be nums of I and nums of I plus 1, and then delta is going to be O minus A. Okay, and by definition there shouldn't be any spillover, right? And here that hit push, and we want a max heap. So we have the delta, we have I. Is that good enough? Yeah, okay, yeah, maybe it is. Right. Just want to print it out real quick. Taking my time on this one, to be honest. I think I know what I want to do, but it, you know, these things is always tricky. Okay, I guess that is the same. Okay, so what happens? I have to do two things. When I merge, I actually missed something. So when I take this one, I mean this one. When I take this one, I merge. Okay, that's fine. But then I also have to take the previous number and then also looking at the newest number. How do I do that to be clear? That's why we have to sort a list, right? You knew what you're doing, Larry. You're just being slow. My brain is not as fast as it used to be. Sort the list. I am doing this wrong though. I don't mean to do it this way. I meant enumerate nums. Okay, there we go. Yes, there we go. That's actually easier than I expected to fix. Not that the other way would be too much harder, but okay. So let's say we do this one, and we remove these two, and then we also have to update here, and then we have to do a lazy on the heap. How do I make sure that this thing is updated if we have two of them? I guess you just have to do more checks. I guess it doesn't update enough. Like Q4 stats. Two people got it, so I think I'm on the right path. Because the way that I'm thinking about it, it shouldn't be that bad. I don't think it's easy, but it's not that bad. Okay. Okay, so then now we process the current thing. Is this what I want to do? No. Actually, what I want to do is also put this in here. Nums I delta. Okay. Okay, yeah, maybe that's fine. Okay, and then now that's it. This will give us the delta and index. Okay, convert it back, and then now we make sure that this is the same. So SL dot and also num sub I is the number. I just put it that way. Okay, so bisect left of index value delta, right? I hope this is fast enough, to be honest. That's good. Otherwise, we continue after popping because that's just delayed deletion. Otherwise, okay. Is that right? Okay, so then now we have this delta, so that we have to process it. How do we process it? So okay, so now num sub I. So we have index. Okay. So well, first of all, we want to remove key, and we also want to remove that. I forget how to. Yeah, let's just put this here for now. Okay, so we're going to update num sub I. This is annoying to code for sure. It's just bookkeeping, but okay. So index, so now we're trying to look at the next number, right? So if we process this number, the next number will not go, right? So we also want to have to remove something like that, but put it in the future. So then here, okay. So this is the value. Okay, so next index should be the next index, right? Okay, so if okay, so then now this thing will contain some delta we don't care about, the index that we don't care about, and the value which we do care about. And basically, now we want to replace it with right? So yeah. Okay, so we have to remove all the stuff at the end, I think. Okay, and then if this is the case, then we actually want to append make this slightly faster because okay, so then now yeah, okay, so this is the new value for SF index. Okay, so we don't need to do these anymore, at least. Because if this is the last element, then we don't add a thing anyway. Right, so okay. So then now we have index, this is the new value, and then the delta is going to be okay. Okay, so this is the new addition. We do remove it. Okay, that's fine. Okay. Am I good here? Now I have to do the heap. That's what I get for being lazy. I have to be not lazy anyway in the future. Okay, the heap is negative delta, index is the same index, and then the new v is going to be new v is going to be a, right? Is this right? No, this is the old delta. No. Focus. I think this is wrong. Because then now its index was 2, isn't it? Okay, so we have to remove this anyway, but we don't care about the value. Well, I guess we care about the value and that's the value, but that's not the new delta, because the new delta has to be the thing that's next. So okay, so we do have to add this as well. So this has to, oh wait, no. Because we only keep track of the deltas, we're missing one item on the sorted list. Okay, I think that's how I get confused. What's the delta in this case? I guess it doesn't matter. We will never use this in the heap, so okay. Right. So we have to put this back. No, and delta is not right, Larry. If we do have a next number, oh no, this is now good again. Do I need this delta? Yes, because I need to verify it. Okay, so then now I and I. Okay, so now we. Okay, that's fine. Do we even care about n index? We don't. We just care about the value. Is that true? Yeah, because that's the current update. So then now this is the new value. But if there's one more value, then we calculate the delta. Okay, fine. And we don't have to remove it because it doesn't affect it. Okay. We just needed to calculate the new delta. Okay, fine. Delta is okay. So then the new value is going to be that's the O, and the O is going to be and new delta is O minus A, and then here we go. I think. Right. And then now we have to update the previous. Definitely have to remove it because we have to update it. And now basically, I guess the delta doesn't matter anymore. I mean, okay, previous index we care about, the delta that we don't. No, that's the value. What is this? This is just wrong. Delta's on the last one. Okay, and then the delta doesn't matter. And now index read2 is the same. We just have to get the new delta. New delta is just read at the end is you go to the new value. So this is always true the way that we have it, I think, because we cannot remove the last value. Because that doesn't make sense otherwise. Okay, so then now this is going to and then this is O minus A. P-index, and then no, O value is the same, just a new delta. Okay, and then now for key and removal. And then at the end, can I get all the items in a way? Right. Man, I'm very slow here, but maybe that's fine. I think iterator works. I always forget. What do I have here? Delta in SL. Okay. No chance this is right, but definitely worth. I think we're close, but maybe not. 932. Okay, so oh, this is a typo. 3259 on list. And remove, so that means it's this. Addition. That's awkward. But this is also the same, that's why. But why? Do I not? Oh, this is S index. How did I make the same typo twice? That is terrible. But why is that? Why am I getting an error here? So the list is going to be so this is looking for this, but why? Why is that on the heap? Because I push something weird. So this one, we're searching for this, but why? Oh, because I have this thing for some reason. But still, why? It should be while k is greater than 0. But maybe that fixes it. 7,715 is definitely not right. Which is fine. Okay. Now we just have to print a little bit clearer. Key. Okay, so now we pause this, and then is this right? Don't even know where this number comes from. Oh, maybe that's from here though. Okay, so k is 2, but we only did this once. Why? Okay, we do this. 036. Do we just not go all the way here? Why? Oh, 036, that's in there. 012. That's also in here. Oh, this key is different. This key is not the other key because I am dumb. Okay, so this is 306, but then now process stuff. Oh no, this is just doing it again. Okay, fine. And 156 is not, it cannot be found, which is fine. Oh, because I have this here when it should be here because it didn't do anything. Okay. All right, I mean, that's fine maybe. What did I get for the first one though? This one. 3. Yeah, okay, that's good, maybe. Now we just have to see if it works for the other one, maybe. I mean, greedy is a little bit easy. Okay, so this is not right. So we have 4. So we don't need this anymore, say. Maybe. Okay, so try to do one. Try to do this one. Three and 15 is 2, is it? Maybe I should do it before and after. Okay, so then now this merges. Okay. It's still 3, that's fine. Okay. And now the next biggest delta is 13. So then that merges that too, that's fine. 3 and 14 is 2, okay. 4, 2, okay. This part is weird, isn't it? Yeah, this merge is weird. Okay. Because basically this part never happened. So then n delta is infinity. Because now we take this is the last number. Okay. And then okay, I see. Okay, it's 2. I don't know if this is right, but at least it works for the examples. Now let's get rid of some print statements and we'll YOLO see if this works. Do I have any obvious examples that could be wrong? And let's try k0 to 0. I don't think we have to do incremental improvements because I think it only makes it better. But all right, well, at least that's a fast, wrong answer. And now my computer is crashing. This is not a good time. What is my computer doing? That could be crashing. I don't even know how to. All right, there we go. Computer crashed for a little bit. What am I doing? Oh yeah. Where? Is greedy not right, or is it just my implementation? I guess we'll see. Interest 39. Or that sounds right, but is my logic right though? So we do 3, we have 6 numbers, and now we have 3 numbers left. Doesn't seem right. No, merging 3 makes, no. It should have 4 numbers, so something is very funky. 1, 2, 4, okay. So 1, 2, 3, 4, okay. So now we have 5, we have 4, 4 to 3. So we have, no. So we have 1, 2, 3, 4, 5, 6 numbers, and then we merge 1 till we get 5. All right. We have 5 numbers, and we merge 1, we get 4. Okay, maybe this is right actually, but the number is not right. So is the greedy wrong? Why is this 60? Because they're, oh, well, no, I mean, this makes sense. We want to take the most significant bit. Is there a DP solution? Am I just like doing it the dumb way? 21 people got it, so it's not that easy still. But I thought it would be greedy, to be honest, but maybe not. I think the implementation is right, but maybe greedy is not the way. Why is it not the way? No, you have to get rid of the most significant bits, and if you have tie breaking on the significant bits, so I don't get it. This one and this one is, do I have the numbers wrong? Okay, you do this. Bitwise calculator. I need a bitwise calculator. So 62 and 3, and it's going to be 2, or it's going to be 63. So 61 is right. How do you get 38? I guess that's the question. I guess if you do these two, maybe? Like if you do these two, then what happens? Then you get rid of the something. I guess it's not transitive, it's the, or not commutative, one of those. I really thought it would be greedy though. Now to kind of rethink my things. I don't think my implementation is wrong. I mean, the way that I do the greedy is kind of like bitwise, but this is tough. How would I do it another way? I mean, okay, in a greedy way. I see. Because I'm locally optimizing, there could be a thing where if you have a chain of them, I don't do the chain because I greed. No, but then you still have to do the other thing. But then maybe. I see. But K could be pretty big, so. Okay, I could see why the greedy isn't working. Is there a DP? I can see why, but no, because you want to, you can only up minus that bit if you do all of those. I see, because I may prioritize a bit that I cannot change. So okay, so then because I may prioritize a bit I cannot change. Okay, I think I have another way of doing it, but this is hard. I gotta stop refreshing. 22 minutes. So then it's just every bit whether we flip it or not, right? Okay, fine. I mean, I already submitted this, so I guess it doesn't matter. Okay, I was wrong about the greedy. Greedy is hard. Okay, fine. Okay, and then now it goes up to 2 to 30, so okay, fine. Then it's either we can minimize or we don't, right? Yeah, okay, I see how to do it. No, because I mean, no, because it does affect things because if you shift them, so it's not just a pure count on all of them. It's not quite that, no. Okay, at least not that naively. That's why I didn't do it the first time, I guess. But because if you do a more significant bit, it may still get rid of it. That's why we had this whole complicated thing with greedy. I thought greedy would actually sort that out, but I can see why that. No, it still should because you're forced to. What am I doing? I think that's the thing, is that it's forced, right? What? Like here, okay, let's see. Right. Like you're forced. Alright, let's take a look. I forgot how to do padding. Lazy. What's with this case? Okay, then you have to do at least 4 to get rid of them, right? So, why am I doing it wrong? Well, what is going wrong? Am I doing wrong? So we do 0, 1, 2, 3, 4. We do this. We remove it. And now we got 0, which is great. And this is just 0. But we still have to remove 1, 2, 3. And then we just merge it to here. But something is wrong. Because the second thing that... Oh, we only get 3 moves. I see. So the thing is that if we I see, I see, I see, I see, I see. Huh. Okay. I see. I have half an hour. Can I fix this? The short answer is because. Okay. Larry, don't explain. I mean, I know you love explaining, but okay. Okay, okay. I see why my greedy's off. Same idea as before, but okay. Okay, then what do we want to do? Do we want to skip a bit? Let's say we skip a bit, then what happens? Okay, okay. Okay, I see. It's greedy. Okay, fine. Okay, okay, okay. I see. How do I change it? Okay. How do I choose how to skip a bit? You already submitted it? That's fine now. Alright, focus. No, no, no. Okay, so we want to do this. Okay, so then if k is greater than equal to count, then n count is not equal to n, then subtract count. Else if count is greater than 0, then can it be that? I don't get it. Why is this not right? Oh, because we do an n, this has to be updated. Okay, yeah, that's right. That's a little bit off, but okay. Oh, it's Is this if? I guess it's I don't want to do the XOR thing. I just do it the dumb way. Oh, still not right, huh? Why not? Oh wait, that's not what I want to do. I mean, what I want to do is then this gets AND with the next bit. Okay, I see what I need to do. Alright, basically I have to check whether this is 0. Okay, I see. I see what I need to do, but I don't know how to do it. Well, each number can only be merged once. So this is still linear. Okay, fine. Yeah, actually, then now it matters whether you go left or right. You can't just, I mean, you can just zero things out, but you have to do it in a greedy way, which is why I had it the other way. Because then you have to. Because it matters which way you go. Huh, how did I solve that? How many people got this? Not many people yet. I see what I need to do, but it's not even just the next numbers, right? Because it matters if you go left or right. Wow. But this is generally the idea that I wanted before, but I don't know how to do it in a reasonable amount of time. Because in this case, well, not this one, and did I no longer have it? Oh well, I lost my other case. It doesn't matter. It doesn't matter because I know what the issue is. I don't know how I could solve it, to be honest. This is a pretty hard one. I don't even have the idea. It's not even like I don't know the implementation and I know the idea. Well, I mean, I have the idea, but I think it's closer to what I had before. But I have to kind of change the function somehow. Change the heap function. I don't know that I know how to do it. And log, that's too many log ends. If we do like sort every time we have a new bit. 30 times 30, that's gonna be too slow. Yeah, let's try it, YOLO. I mean, I have nothing to lose, I guess. How do I write it? And even if it's too slow. No, but you can't even do this in a greedy way. It's like some funky DP thing, but I don't know how to do it. Basically, because you have to optimize for each index. And you have to actually take a look to see if you can flip them off. It's not even a guarantee that you'll flip them off on the future ones. So you can't even do bit by bit. That 5-minute penalty sucks though. Greedy doesn't work, at least not like this. And even sub-greedy doesn't work if we skip it. It has to be some sort of DP then. Does it matter if you change it to the left or to the right? I don't know. Maybe it was closer, I don't know. Did I add this? I don't know if I did, but okay. I think I had the wrong thing before too, but oh well. Okay, but then now we have how do I write this? Okay. That's not good, but it's a start. One, 3, 2, 0, 0. It's 1, 3, 2 right there. It is. Oh, I guess this is weird, but so the 2 digits, but why? We don't have enough, do we? Did I messed up? Oh no, whoops, that's why. Pretty well. 13 minutes. I don't know where I get it, but why? Oh man, I am illiterate. 3215. It may time out, but well, maybe I have a wrong answer. but it's freebie at this point, so I'm not that worried about it. Should be 0, but I get 7. Why do I have 7? One, two. I think I'm in 5 numbers. I think I'm doing this a little bit off. For 32, that should have nothing. Okay. This should not have changed anything. Why is that? I feel like I'm close, but I'm off by some weird things. Since they are equal, so we don't change it. That makes sense. Oh no, this is afterwards, so okay. So you get rid of this. Okay, that's fair. And after oh, so this has to go all the way back. Okay, how did I do that? So this only happens if it is 1, 1, right? Okay, so now it properly merges. Okay. I mean, again, you know, it's freebie. 10 minutes. If I don't get it, I don't get it. But 23. Am I missing a number? I'm like doing something funky. No, I removed 3, so there should be 2 numbers left, and I get 23. Why do I get 23? So we want to lose 32. And the answer should be 4. How is this not right though? Okay, so you get rid of this. Oh, no. So, okay, so this one we end this and this. Oh, this is the part where you want to go forward instead of backwards. So I was wrong a little bit on that it doesn't matter. In this case, it does matter. Huh. Because it should, yeah, because this would be 4 instead of doing this suffix. Oh, and then this is 0, so that's 0. That's really wrong. How do I do this? Can I do it? I mean, the idea is right, but I'm not choosing the right things. Okay, let's say we go back to here. I think this only applies if the first number. No, it's still wrong even if I don't do it that way. Because then now this eats these things. And now this is 0 and this is 0. Can I represent this in a smarter way? No, because if I do a little bit too greedy, then we'll make this all 0 and that'll just be wrong too. Huh. And it matters, like for the example here, there's another case where this one would maybe want to merge with this one and not this one. So it's not always necessary. Huh. Yeah, I have no idea, to be honest. This is hard. Like, I have the idea, but I'm not going well into sorting. I mean, unless we do another sorting thing, but that is really expensive. For our first search, I don't even know if you could do it that way, because you're taking that. So there's some like exchange argument with sorting, but I don't know that I could get that done in 5 minutes or even an hour. Okay, so definitely identified that we can remove the 32-bit, but it's the extra bits that makes it so complicated. Like, I don't know how to do this with DP, but do I do it with DP one at a time? No, that doesn't even make sense. Because then now you're optimizing for things in the future that you might not even know. Like, it may just be optimized in another way. Wow, I mean, I think I got some of the ideas, but I just don't know. I guess I have to wait for the I'm missing one property. I don't even know if this is fast enough, to be honest. But so it really matters which way you go. I mean, you have a choice of like things, but because then now you have basically I think I could No, then you have to, oh, I don't know how to do it. Yeah, this is so hard. Huh. I don't even think I'm on the right ballpark, to be honest. Like, it's not like I think I'm close and missing something. I should have refreshed because then now I don't have the catch case. Maybe I have it here. But I don't know how to do it. It feels like it's going to be greedy, but yeah, I mean, just 1 minute left, I think. So I'm not going to solve this one. 49 seconds. I mean, I had promising first 3 problems, but people got it very quickly too. Like, people are very smart. I thought that I had a chance. I had a couple of ways of attacking it. I don't really know how to do it. I mean, these are definitely not interview problems. I don't think I'm actually 50. Maybe people, I mean, 67 people have solved it or something, right? I mean, this guy is like ridiculous, right? And he's 55th, so I don't feel that bad about it. But still not. I feel like, yeah. I don't know if I should be able to solve this. I feel like I'm close, but I don't know if I'm missing some weird thing. Alright, well. Let's take a look. I don't think I have an idea. So let's take a look and cheat. Like, it's not something that I think I could grind out. I grind as much as I could have. So let's take a look. This is kind of what I have, right? I don't know what I'm missing here, but seems, I mean, this is very close to my solution. I think I'm just missing some very little thing. It seems like. I don't know what this and or is about. I guess it's just for skipping. Oh yeah, this is just for skipping, but we could, there could have been otherwise. What is so far? Is so far the thing you return? No. I don't know what this does. All right, let's see if there's another code that's a little bit clearer. Well, this code is very clear, but this is very close to mine, but I don't. How do you do? I mean, did I misunderstand this problem? I mean, this is just binary search, but I see what they're doing, but they did it without the merging, so I was very close. I mean, it's not binary search in the same way, but I mean, I know what the code is doing. I'm trying to figure out if I can understand it. I mean, this is very close to my ideas, but I don't know how they could do it without the actual like merging. Like I had very similar ideas. But there's, well, this is just more binary search, kind of. I don't know if that's true, but there's 80 numbers. It's just to make it impossible. I mean, I see the code. I just don't understand the logic. Like, Okay, apparently only page 1 answers. Let's see. I mean, all the structure is the same, but basically you have possible answer and then you test the answer. I see, I think. Maybe, no. Okay, let's see if I can get this. So the bitwise is otherwise. Oh, so this is the way that you do already subtracted, I guess. But I kind of see, I think I was trying to do it bit by bit, but it's a very hard concept. I'm trying to see, I mean, I think I understand it, but I'm trying to think whether how do I even get to a place where I can explain it. Basically, you have all these things, and then now we go. So then now it is possible, sure. But basically, I mean, it's not binary search though. It looks structurally very similar. Okay. I see. This is actually kind of hard, but I don't know how to explain it yet. But let me try to get the answer for now. Let me just see if I can code it up first. Right. And then basically here is saying if. Yeah, okay. It's not even that. Okay, and then. That's a hard one. I don't know. I mean, I think it makes sense, but I don't know if I could. I mean, yeah, that is so. It is so clever. I don't know if I could reproduce it, but. And basically now we're trying to see if it's possible. How do we see if it's possible, right? Basically, if similar to this stuff actually. Okay, so let's say web comes to 0. Okay, do we do this step, right? That's what it's asking. If this prefix is equal to this prefix, then what does that mean? Yeah, maybe this would just be this is a little bit cleaner. Okay. So we're trying to see whether okay, to merge the thing with the current one. Otherwise, what happens? I have to think through how to do it. How do you count the what is the number of groups? Okay, let's start with one number at a time, Larry. Okay, so let's say you have one. You have one. What am I saying? Okay, so let's say we have something like that, right? And the thing is that we count the number of ones. So how many operations does it take to get this to all 0, right? It's going to be the number of ones. Okay, that part is easy. But then what about the prefix? What if it's like, well, the prefix already is set, so it's only for this bit, right? I'm still stuck on doing it one bit at a time, I think, in my head. That's why. Okay, because what happens if you have 2 bits and it's something like this, and you're testing 0, 0, then what does this mean? Because then now here it's 1. So if it's not equal, then it has to merge, because it can only get better. Okay. So okay, so if this is not equal, then we have to merge. And then that takes one count. Maybe off by 1, but that's fine. Otherwise, it is equal to target. So then we don't have to merge. Then we just do. Okay. Right. And then if steps is, if k is greater than or equal to steps, then we're good. And then always equal to target, and that's it. Am I missing something weird? I don't know. Well, definitely missing something weird. Steps take 5. Oh, this is a little bit. No. Okay, so there's 1. So it takes 1. Maybe steps minus 1, but that shouldn't matter. There should not be 5 steps, because num sub I, this should be 0 and this should be 0, right? So steps should be just 1. I mean, even if it's off by 1, this is not close. Why? Oh, I'm using I in 2 places. Larry, what are you doing? I still think I'm off by 1, but that's fine. Okay. Well. Oh, no. This is I. The other thing is J. That's why I got confused. Alright. Okay. I mean, this is not right, but that's fine, because I think we're off by 1. Okay, that's good, maybe. I mean, it's closer. It's not quite right, but... to get to 0... Target is 0, and it takes 4 steps. That doesn't seem right. And then oh, I guess 4 steps is the most. Is it? So this 1 Am I off by 1? Maybe. $37, and then 4, and then 4, so that's 3, and then 0, and then we start a new one. Am I off by 1? 440. Oh, I guess I have to do something like still not right, but something just kind of I'm missing something weird. Why is it 7 is fine as a prefix, but then we get rid of 4, which is no go, which is true. But then this one should be true, right? So it's my conditional one. Prefix is all the way down to 0, and you have 7. Alright, and then you try removing 0 and then 3, which is no good. But then something is off here. If it's no good, then this should be a 1, right? Why do I have 7? Oh, you have 7. 7 is good. Somehow. My things are really weird printing. Alright. Alright, so 7 is good. Okay, 3, no good, no bueno. So why? Get rid of. So 7 is what? 1, 2, 4. So 4 is good. Isn't it good? Oh no, this means that the 4 digit is a 0. This is actually wrong then, right? What number do we have here? This is kind of tricky. Okay, so we have this. Okay, we got rid of 1, 2, 3. Okay, that's fine. And then here, 0, 0, we have 1, 2, 3, 4. That's also fine. This also gets out, so that's good. I think I'm doing it in a weird way. I don't think my merging is quite right. Basically, what we wanted. The merging, even knowing the answer or knowing some idea of the answer, it's still pretty hard. Oh, I'm still struggling. Okay, so what does this mean? Okay, so that means that I can merge all these away. So we want 0, 0, so we have this, we merge this with Gucci, and then we start this one, still no, and then do it. That's why it goes down. This digit, is that true? Now we need this digit. Why is it giving me? Okay, I think that no. Why is it giving me 3 when it needs 4? Am I looking right? Oops. So basically, it's going 1, 2, 3, and then 3, and then but then 4. So I'm doing something wrong with this logic. If it is equal to it, then you're fine, and you start a new one. Okay. Why is that off by 1? Why is it only returning 3? Okay, so you start 37, get a step. 1, 2, 3, 4, and then it's 0. Why is it only putting 5 numbers? Is that right? There are only 5 numbers, that's why. But how is that? 1, 2, 3, 4. I mean, I have this step plus 1 or minus 1. I think that thing is kind of confusing, but what if the first thing is right? Okay, fine. I think the way that I structure this is a little bit awkward. Let's just start by number 0. Why did I get negative? Oh, because I have negative 1. Okay, now we don't have that anymore. Okay, still wrong though. Why is it giving me 3? So 4. Oh, it starts at steps 1. No, it doesn't. It doesn't have to merge yet. And off by 1 is still struggling. Okay. This is the 7-bit. So the current. So then I hate this interface. It's so like I have to scroll up so much, up and down so much. Okay. Why is this 1? I guess that could be 0. That's fine. That's definitely wrong. The prefix should be 0. So, okay. So this is not true. So then you add it. Da, 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 da. What? I don't get it. I don't get what my code is doing. Well, I'm also like delirious. So I don't know, maybe that's just me. That's steps. So 40. Current is 4. Then it gets the new number. I'm definitely doing this wrong, but okay. So then now it is you go to 0 on the next one. So then it just resets it. But that's not true, right? Because now you have to add a new one here. So so then if this is 0, then you're done. Kind of. Then you have to merge it with the new one. Man, this should be basic. I'm almost embarrassed. Even knowing the answer, it should not take me half an hour to implement this. So, okay. So then now, you start with a new one. Maybe steps is the wrong way to think about it. Maybe groups is the right way to think about it. Okay. Because then now there's one group, and then now if it's 0, then you have another group, and then how many groups can you have? The number of groups that you can have. It's like n minus groups or something. Maybe off by 1. I feel like that's like really No, this is a new group. I feel like this is mostly the same, but does it handle off by 1 differently? Why am I so dumb today? You have the idea and I just can't implement it. Okay, how do I count the number of steps, Larry? Why are you so bad at this? Okay, so let's say we're trying to go 0, 0. How many steps prefix do you get? Let's say you get a 0. Then what? Started the next one. I don't get why this as well. Yeah. I mean, this is just the code that I had, but I have to merge it back. This is still wrong, but I just can't get it. I don't know why I'm being so poorly on this. Let's just focus. Focus. So my problem is kind of hard today. Usually it's been code, but today not so much. Okay, so then now it has two numbers and it hits a 0 on the third. I see. Do you? Why? 7 is right. Why am I keep on debugging this? It is just that it is not getting the 2 and the 1 correctly. Right? Two and the 1, which is giving us the 7. Right, the 7 is fine actually. Yeah, I'm debugging the wrong thing. The 4-bit is fine. Do I have to print statement? The 4-bit is fine because 1, 2, 3, 4. Yeah, and that's expected, Larry. That's why you have a 7. But here you have 3. 1, 2, 3. I'm debugging the wrong thing for the wrong. Oh man, I am just being silly. Okay, so why is this giving me 4? 18, 2, 2, 2. So that's good, maybe. One step, and then now. Oh, because this is should be 2 as the first prefix, right? Oh, I have to. Do I? Because it has some like 18-bit, so then we can. What does 18-bit mean? It means that we already. Well, okay. So this means that we start out with a step. But then here, we would already get the 2 after one thing, right? Yeah. So then the step is 1, okay. Then we start with a new number. Go on. So we start a new number, 2, and then 2. How do you get 4 from 2? Do I double count? I think I double count on the last step. So this is not equal to that. Yeah. Oh, I see. So I double counted on here. The way that I'm doing stuff is really dumb. Okay, fine. So we don't need that. If this is the last one. I'm like off by 1 in some weird place. Okay, so on the last step, we either do this or this. And then this is such a weird hack because I suck at programming. Okay, let's YOLO submit this real quick. I can't believe it. I don't know. Well, I was debugging the wrong thing for a while. So, I don't know. Yeah, ooh. I don't handle one item correctly. Okay. Well. I'm curious. Makes sense. Is that a special case? Do I need to handle it specially? I guess so, because I always have do and then this never loops. If it never loops, then we subtract the steps. Oh, because we don't take account all of them. Whoops. Okay, fine. Okay, fine. I mean, we had this case, but I was just, I kind of got so distracted by other stuff. Well, mostly that I'm dumb, but okay, there you go. Oh no. So it definitely should be all of these two, but very sad. I'm gonna target, diversify, okay, and steps. You get the prefix, so yeah, okay. One of these should be 0, right? Oh, no. How did I get this? Is that the input? I forget. No, that's not the input. Okay, that's just the other one. This is one of the bits. What's it, 32, whatever? 32768. Wait, did I? What is this? Huh? What is the? I don't even. I need a bitwise or a calculator. Hang on. Okay, so the bitwise all of these two numbers is just this. So why am I getting like this weird number? What is this? Oh, that's the prefix. What is that? Target? This is not easy to read. Oh, because it thinks all of them are on it. Because basically this thing triggered. Which is fine, right? Because that means that we don't update this. So what's the matter? If we're up by like 32,000, that's exactly the number that we should be subtracting from. Yep. Right? Like we... To be honest, I'm just like way out of gas today. Yeah, so that's... I mean, it's off by one somewhere too. But we'll fix the other thing first. Huh. This is definitely wrong, right? Because they're both even numbers. So we shouldn't have an odd number thing. What is the odd number thing? Okay, so 1. So 0 with 1 step. Why do I have 1 step? I have 1 step because okay, so this is equal to whatever, but this is not equal to target. Oh, that's not right. It should be... What should it be? It should be, or worse, so it should be something like this. Okay. Hopefully that's it. Oh, this is actually also applies to here, I think. Oops. Yep, okay. I did not update it sufficiently. Come on, please. Oh, man. This is just an abuse today. 46, 47. You have 2, so, and the 3 are the numbers, so that is true. There really should not be any way of so it thinks that it can do in 2 steps for some reason. Alright, let's take a look. I don't know why this isn't split screen. Okay, okay, let's take a look. We just don't care about the single digits, I guess. Is this the stuff? I don't even remember what I'm printing anymore. Is this one? Oh, this is the target. Okay, so the target is 46. We have 40. That should be good. So, and it's good. So I have no more steps. All right, that's fair. Start a new one, 47, okay, we end. Also good. Something is off. Am I adding the right numbers? How is it off by 1 though? Okay, so 47. Okay, so how will we count it? So this is 0, so we're trying for 0. This is good. We see a 47, that's 1 number. 2 number, 3 number, that's what we should expect, right? So then now, ooh. So this should, because this will add it to 2. I think I'm just like off by 1 in the real place. I think this needs to be here in that case. But that is just the way that I write this code, I'm not very happy about. Yeah, I mean, sorry friends, I'm just kind of recollecting myself and trying to figure out what the hey is going on here. And how I could have done better. I mean, this loop is always a little bit awkward. I guess this should be an else. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, this explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.